Welcome back to the series of linear regression. Today we'll be seeing more about linear regression. So coming first, what is this best fit line in linear regression? Let me just take the pen. Okay. So what is this best fit line in linear regression? So in last example, we saw that linear regression puts a graph, nothing but it assumes or it takes a line and accordingly it finds the data points. Okay, so this is what the line or the linear line it assumes. So the thing is, in linear regression, the best fit line is a straight line that most accurately represents the relationship between the independent variable and the dependent variable. So what do you mean by the best fit line? Nothing but, example, if I have two variables, this is nothing but your x and y. The best fit line is a line between these two variables that it represents the relationship between the independent variable and the dependent variable. Here in this case, I think this is my best fit line. So this is the line, this is the best fit line to my regression model, where it finds the relationship between, or it establishes the relationship between the independent variable and the dependent variable. So this is what the best fit line means. So we'll see how does it looks. See, in this example or in this, you can see that what is the goal of the best fit line? Nothing but the goal of linear regression is to find the straight line that maximizes or minimizes the error between the observed data points and the predicted variables. So you guys can see in here. So let me just zoom. Okay. So you guys can see in here that I have my x variable and my y variable here, and the line going here is nothing but the best fit line. Why this is the best fit line? Because see, there are data points over here, there are the data points, whatever the data points are here, and this is my best fit line where it can go through. Okay, so this is the line which minimizes the error if my line goes from here. So what is the use of that line? Nothing but see, my data points are all over here. I don't have data points here or lying here. So this is not the best fit line. Neither this is my best fit line. So linear regression identifies the best fit line, or the goal of the best fit line is that it uh, uses the best fit line which minimizes the error, between the observed data and the predicted values. See, what do you mean by this observed value and the predicted value? Okay, so let me just give you an example. Here, what are the observed value? Observed value is nothing but the values which are already present in our data set. Nothing but the red points, whatever are there, right? That is nothing but the values already present. Now, what if I want to see for this value, this red dot data? Okay, so what if I want to find, this is nothing but the observed value. What I have, this is observed value, and this is nothing but the value which is predicted by my algorithm. This is nothing but the predicted value, and the difference between this is nothing but my random error. So understanding, let me just say you once again, this is the my observed value which is present in my data set, and the regression model predicts this as the value. So the difference between these two is nothing but my random error. So this is my predicted value pi, observed value yi. Okay, so this is that, and also I have a slope that is nothing but tan theta equals to theta 1. Okay, so this is my the best fit line, how it looks. And also coming here, this is the equation, of your best fit line. So what is the equation of any straight line? So the equation of any straight line is equals to y equals to mx plus c. So this is the equation of a straight line which linear regression model thinks and plots the graph or the line. So what do you mean by m, x, c, y? We'll see into the later classes. Okay, here only they have given. See, you guys can see. Just a minute, let me just, okay. So here y is called the dependent or the target value, nothing but this is our output, and x is called the independent value. This is nothing but my input, and also as the predictor of y, nothing but my x value is nothing but predictor of y. I am predicting y on the basis of x. Okay. And what is the equation of best fit line? Last we saw that what is the equation of best fit line? This is nothing but the equation of best fit line, that is y equals to mx plus b. Okay, we can take any values b, c, whatever it is a constant. Okay, so where y is nothing but the predicted value, nothing but our output, nothing but our output, and x is the input. This is what my input, this is what my input it, and m is the slope, how much y changes when x changes. So here very important point, my m is nothing but coefficient of x. My x is nothing but the coefficient of x, nothing but if my m is 2, what will be my x? It is 2x. What will be my y? It is nothing but 2x. So m is nothing but the coefficient, nothing but in what values my x changes. Okay, m is the slope of a line, how much y changes when x changes, or else we can also say m as the coefficient of x. Okay, and here b is the intercept, the value of y when x equals to 0, nothing but if my line starts from, if my line starts from origin, if my line starts from origin, then my b is equals to 0. This is nothing but my intercept. If my b starts from here, nothing, my line starts from here, this is my intercept, whatever the value it is, that is nothing but my intercept. Okay, I guess everyone understood. It is very easy. What is the equation of straight line? That is nothing but y equals to mx plus bc, whatever you want to take. And here y is the predicted value, that is nothing but my dependent variable or my output, and x is the input value, and here m is the slope of the line, nothing but we can also call it as coefficient of x, and b is the intercept, the value of y when x is equals to 0. Okay, so I guess everyone understood this equation of, yes. So we have seen what does the best fit line is, what is the formula for that, and we have seen what are other values seen. So we'll just break it down to by step. We'll see what is the interpretation of the best fit line. First and foremost is my y. What is my formula? Y is equals to mx plus c. This is my formula, what it is, the best fit line equation, y equals to mx plus c. What does this m? M is nothing but the slope of the best fit line. Okay, the slope of the best fit line. Taking an example, how it changes, how it affects my line. If the slope is 5, nothing but if my m equals to 5, then what will be my y? So simple equation solving, that is nothing but y equals to, my m is taking 5, what is my m? 5 into x, plus thinking that my intercept is 0 starting from origin, that is nothing but 0, so y equals to 5x. How my y changes? Y changes 5 times of x, so this m is nothing but my slope, and it indicates how much the dependent variable y changes with each unit in the independent variable. So this is very little bit of confusing, but don't confuse it. Your m is nothing but the slope. Taking an example here, I have took the example of m equals to 5. So how it changes? It changes something like this. Okay, and when we speak about linear regression, it has so many advantages and also a very big disadvantage, that is the assumption of our linear regression. So what are the assumption of our linear regression? The first and foremost assumption is that it assumes our data is linearly distributed. So it assumes that, the method assumes that the relationship between the variables is linear. But every time it is not possible, or it is not the case that our x and y variables are linearly related. It might be not linearly related sometimes. If the relationship is non-linear, or linear regression might not work very well. So you guys can see here, this is nothing but your how the linear data looks like. This is how your non-linear data looks like, and this is also non-linear data. So now if I put a line, it will work properly, but here it won't work properly. And now what about this? Here it won't work properly. If I have such kind of thing, then it will work. So this is the assumption of linear regression model, that it assumes the relationship between x and y is always linear, and it is also sensitive to outliers. Here in this you can see these values are some outliers which are lying apart from our range. So whenever we have outliers, it is very skewed here. So the conclusion is that whenever we have linear relationships, then the linear regression works very well. If not, the model will not work properly. So stay tuned guys. In next classes we'll be seeing the practical implementation, so we'll learn to see how this model works. Stay tuned and follow Fortune Cloud for more videos. Thank you so much.